According to Francis D.K. Ching, the central task of architectural drawing is representing three-dimensional forms, constructions, and spatial environments in a two-dimensional surface. Hello, I'm Gwen, and today we will be talking about the different types of architectural drawing systems. There are three major drawing systems: multi-view drawings, paraline drawings, and perspective drawings. Let's first focus on what multi-view drawings are. They are two-dimensional depictions of a subject and don't reflect what we exactly see in visual reality. However, they provide easier understanding of the subject's measurements and even allows us to study its proportions with its other views in scalar comparison. Under multi-view drawings are orthographic projections, which could depict a minimum of three main projections: the top view, sometimes called the plan view, the front view, and the side view. These views can be expanded to have the side view have a right side and a left side view, have a back view, sometimes called the rear view, and very seldomly, but possibly, have a bottom view. With orthographic projections, architects, engineers, and simple viewers alike could easily understand the subject's information, like descriptions, sizes, and arrangement, that is crucial to its creation. Now let's hop on to paraline drawings, the second of the major drawing systems. According to Ching, they combine the measured precision and scalability of multi-view drawings and the pictorial nature of linear perspective. Under it are two major types: the axonometric projection and the oblique projection. Focusing on axonometric projections first, they derive from the Greek word axon, or axis, and the English word metric, or measurement. The word axonometric then means that all principal axes, x, y, and z, and the measurements made on them are drawn exactly to scale. It is also when, according to the book Technical Graphics Communication by Gary R. Bertolini, the object is rotated around one or more of its axes to reveal multiple sides. There are mainly three ways an axonometric projection can be drawn: isometric, dimetric, and trimetric. Isometric projections, when measured at the corner where its lines converge at a point, its angles all measure equally, and all three principal axes are equally foreshortened. These axes will always and forever will be 120 degrees apart from each other. If we draw a horizontal line in which the corners will intersect at a point, the measure of these angles will be 30 degrees. Dimetric projections, when measured at the corner where its lines converge at a point, only two of its angles all measure equally, and only two principal axes are equally foreshortened. There are many ways to draw dimetric projections, but here are two simple examples, one at a 45-degree angle and another at a 15-degree angle. And lastly, trimetric projections, when measured at the corner where its lines converge at a point, none of its angles all measure equally, and all three principal axes are foreshortened at different rates. The second type of paraline drawings are oblique projections, of which there are two main types among others: plan obliques and elevation obliques. To create plan obliques, we simply take the plan view and tilt it at a desired angle, then draw the receding lines to scale upwards according to its elevations. To create elevation obliques, we draw an elevation flat on the picture plane and draw the opposite elevation further at a desired angle. The distance between these elevations, or the receding lines, must be to scale. These obliques tend to seem to look distorted, hence there is the option to foreshorten the receding lines to 3/4 or even half of their true scaled length to lessen the appearance of distortion. The last of these major drawing systems are perspective drawings, of which linear projections are under. There are three very well-known types of these projections: the 1-point, the 2-point, and the 3-point. All of said projections play with these major elements. Vanishing points are the most important, as it is where all lines will converge. The 1-point has a singular vanishing point and has an effect of bounding the view within a frame. The central vanishing point can also be manipulated to give emphasis, and this is where the line of symmetry perpendicularly intersects. The 2-point has two vanishing points, which can or cannot be on the picture plane. It is the most commonly used of the three, and is dependent on the viewer's angle of view, which can be on a worm's eye view or a bird's eye view. And lastly, the 3-point, which uses three vanishing points and is also dependent on the viewer's angle of view. This projection is the only one that can depict very high-risen structures or even very elevated or sunken views. And that's it. Thank you for listening.